Welcome back, Rituals, to our review. And this time around, we are on question 9. Okay, they're saying that in the diagram below represents a printed poster. Rectangle ABCD is the part on which the text is printed. This shaded area ABCD is 432 centimeters squared. And we're given that AD is equals to X centimeters. So the length of AD is X centimeters. ABCD is 4 centimeters from the left and right edges of the page and 3 centimeters from the top and bottom of the page, as indicated right there. Okay, so in 9.1, they want us to show that the total area of the page is given by that equation right there. Okay, so now let's analyze this information. They gave us the area of ABCD. Okay, and they give us the distances away from the edges of the paper. Okay, so it means that what we want is the entire length of the paper and the entire width of the paper. Okay, so surely a diagram should help us see what they want right there. Okay, so maybe I could just indicate right there on the paper. So let me change a pen here. Let me use red. Okay, so they told us that X AD, so that length right there will be X centimeters. Okay, so this means that the entire length of the page right there, L, right? Let's call this length right there. Now this would be 4 centimeters plus X centimeters plus the 4 right there. Okay, so it means that L, if we call that the length, will be X plus 8 centimeters right there. Okay, now what we need would be the width, right? L, or the height in terms of, in this case, could be anything that you want to call it. So now what do we have here? We're told that this guy right here is some 3 centimeters as indicated here. And this one right here at the bottom is also 3 centimeters. So what we need would be the length of AB. Okay, so we're not given the length of AB up here, so we should calculate the length of AB. So you can either use AB or DC, does not really matter. Okay, now let's calculate the length of that guy. Right? So we're given that the area of ABCD is equals to, well, that would be length and width right then. So we're given this value of 432 equal to, and now you can take one of these right here, that would be X multiplied by its width. So it means that the width of this rectangle will be, let's divide both sides by X, and you get that the width is equals to 432 over X. So it means that this right here, DC will be 432 over X, like that. So now when I want to calculate how long this paper is now, it would be this 3 centimeters plus this 432 over X plus this 3 down here. So it means that our width here will be 432 over X plus 6. Okay, so now what does this mean? It means that the area of the page, we have every information now to calculate the area of the page. Let me write there, that's the solution for 9.1. It would be the length multiplied by its width right there. Okay, so now what would this give us? Now let's substitute in the values that we have for length and width. So in this case, we're going to have our 432 over X plus 6 multiplied by multiplied by, what do we have there for L, which is going to be X plus 8 right there. Okay. So now this is just the distribution of the values, isn't it? This should be the distribution of the values. So what we are going to have here, X multiplied 4/32. So we're going to have 4/32 like that, multiplied by, here we're going to have 6X, and we're going to now multiply by 8. So when we multiply by 8, we're going to get 3, 4, 5, 6 over X. And now you're going to have 8 multiplied by this 6 here, and you're going to get a value of 48. Okay. So now these two are like terms, 432 and 48. And we're going to arrange them in such a way that this is what we have up here, isn't it? So we're going to have 3, 4, 5, 6 over X plus 6X. And now I add 432 with 48, I get the value of 480, like that. Excellent. So that's how we would approach 9.1. So we have shown. Okay. And now let's see on 9.2 here. Now in 9.2, they're saying determine the value of X such that the total area of the page is a minimum. Okay. So now in this case, I want you to think of functions. Okay. I would like you to think in terms of functions. So now whenever if you have a minimum happening, you can have a minimum happening if you have a function where, like a parabola in this case, you see right here, this function has a minimum, right? And if they were talking about a maximum, they would talk about something of that nature right there. If maybe it was concave, down, and this one right here is concave up. So now they want the value of X such that we're going to have a minimum, right? So this is related to the turning point, the X value of the turning point of that function in that case. So now the moment they speak about minimums, first things first is that we want to derive whatever we have. We want to derive whatever we have, then equate it to 0, because at the turning points, be it a maximum or minimum, at the turning points, the gradient will be 0. So that's when we're going to equate that entire thing to 0, the derivative to 0, and then we are able to solve for the values of X. Now, in some cases, you will find that there might be 2, 3, or in this case, there could be two values of X. Then you check which one would best suit the situation. Now, if we ever calculate the value of X that would be negative, in this case, it wouldn't make any sense. You cannot have length or distance that would be negative, isn't it? Or if you calculate 0, well, yeah, maybe we could have such a value of 0, right? But then right here, you see that for this area to have any dimensions, for this ABCD to have an area of 432 in the first place, it means that the value of X here couldn't be 0. So you'll try to make sense of the values that you're going to receive. So now this is what we have here. AX is equals to 4, 5, 6 over X plus that, like that, isn't it? So now, as I've indicated, what we are going to do is we are going to derive this guy. So now I want to place this in such a way that it is friendly for us to derive. So I'll just rewrite AX as this value here. 4, 5, 6, x to the power -1 like that, plus 6x plus 480. Okay, so now when I've placed it like this, now I can derive. I know that this will be the derivative equals to, so now I'm going to use the power rule in this case. I'm going to have negative in front, x minus, now to the power -2, plus, and this right here would just be 6, isn't it? And the constant will definitely go away. So now I have the equation of the derivative, okay? Now, what I want to have is the value where a minimum, or in this case, a minimum is going to occur. So what am I going to do? I'm going to equate this entire thing to 0, and then I have 3, 4, 5, 6, and I will have it like this, over x squared plus 6. Okay? Now I can move this guy to the other side. So I have positive 3, 4, 5, 6 over x squared is equals to positive 6, like that. Okay. So now I can multiply both sides by x squared. So I'm removing it from the denominator. I'm going to have 3, 4, 5, 6 equals to some 6 x squared. Divide both sides by 6 because we want to separate this information. Divide by 6. Divide that by 6. So we're going to have x squared is equal to 576. Well, now I'm looking for the values of x. Okay, so we take the root of both sides. Now we know that quadratic equations should produce two values of x. Now in this case, we should have a plus minus situation like that. Now one of the x values, it means that we are going to have plus minus, we're going to have 20, 24. So this means that one of the x values is negative 24, or the other x value will be a positive 24. Like I said, we cannot have a negative value for distance. Yes, this is a solution, but for this case, for all practical purposes here, it cannot be negative. So we're going to say, therefore, the value of x should be 24 centimeters, such that the area is at a minimum. Thank you for joining me in this one, and I will see you on the next. Cheers.